Hi, everybody. So we are now starting chapter 7, which is continuing on with geometry. And what we're going to be doing today is we are going to be focusing on scale drawings. So this is a really important part for, let's say, construction if you happen to have blueprints and you want to see what does the original drawing compare to, how does the original drawing compare with the actual final product. We're not going to necessarily be talking about blueprints, but we will be talking about other things where scales can be important. So the first thing is knowing what a scale is. So that is a ratio of a drawing's measurement to the actual measurement. So hopefully you recognize this, especially since I put right there. This was a map of the surrounding area around our school. So a scale is always going to be written as the drawing compared to the actual scale. And for example, this scale is 1 inch is compared to 1 mile. Now, can you find on the map where that scale is located? Hopefully, you notice it down there in the corner. It's very small and it's not written the same way as this ratio here, but it is written the width. Now, at least when I did this on my computer, the width was about an inch, and it says that that is supposed to represent 1 mile. So then we could easily just draw. I'm going to try to do a better job of it. We could draw then a length right there. We could copy it, and then we could just paste, and we could use that then to figure out some distances. So, like, for example, sometimes when I go from school to home, I need to take Highway 100. So it's about 4 miles from the school to Highway 100. Now, when we are using scales and we're trying to solve for values, we are going to use proportions. So here is a picture of a tree. We're going to say that the picture is 6 centimeters tall. We are told that the scale is 1 to 125, and we are going to use that in order to figure out what is the actual height. So, in order to get the actual height, we'll think of the scale is already kind of set up to help us because the 1 to 125 is kind of like it's saying 1 is the drawing and then the 125 is the actual. So then we need to set up another ratio that is also going to be in that form. 6 centimeters is part of the drawing, and we don't know the height, so we're just going to call that x. Then we are going to set up a fraction, and I'm going to say, let's do 1 over 125 equals, and then we're going to put this as the second fraction, 6 over x. So we've set up two fractions, we made a proportion, and then we are going to cross multiply to solve. X times 1 is just x, and then 6 times 125, let's see, we're going to get 30, then that is going to be 12, and then 3 is 5, 1, so 750 is what I get. And then we just need to pay attention to our units. It said that the original height was centimeters. We were not told that we needed to convert it all. So it turns out that the actual height of this tree was going to be 750 centimeters. Okay, so we have a drawing of a refrigerator here on the right, and we are told that the actual height is going to be 4 feet. So part A is asking, what is the drawing scale? So we already know that the height of the drawing is 1 inch, and then we also know that we're going to have 4 feet representing that height as well. So those values represent the same thing. We should write that as our ratio. We should include units as well because the units are different between the two. 1 inch is going to be compared to 4 feet, and so that is the answer. That is the answer for part A. Then for part B, it is asking what is the actual width of the refrigerator. We are told that the width of the drawing is 3/4 of an inch. So kind of like what we did in the prior example with the tree, is that we should set up another ratio using this, and then we don't know the actual, so that can be our unknown x. Therefore, our second ratio will be drawing to actual. 0.75 inches is compared to x feet. And then we can set up our proportion. So let's do 1 inch over 4 feet equals 0.75 inches over x feet. Now in this example, even though our units are not the same, we are still allowed to cross multiply. So when we do that, we're going to get x times 1 again equals x. Now we have to do 4 times 0.75. And let's see, I know 2 times 0.75 is going to be 1.5, so then I double that again. That is going to get me 3. And because, even though it says 1 foot is to 12 inches, our proportion took care of the units for us. I don't need to multiply this answer by 12. Besides, that wouldn't make sense. 12 times 3, we're not going to have a refrigerator that is 36 feet wide. Also, we don't want to divide this by 3 because then you would say that it is 0.25 feet, and that's way too small either. The correct answer is that the width is 3 feet. Okay, so in this picture, you are given a drawing of a soccer field and you're told that the actual soccer field has a length of 100 meters. And what I want you to do then is to find the drawing scale and then also find the actual width. As a reminder, in the Sabas book, it defines length as the longest side. So use that to help you answer this. Pause the video, and then when you are done, I will give you the answer. Okay, now that you have tried this, so we're asked for the drawing scale, and I told you that the length is the longest side. So the longest side is clearly the 5 centimeters. That's also where the 100 meters is going to go. So we're going to set this up then, and I'm going to put 5 centimeters to 100 meters. And for our scale, we really should be putting this into simplest form. So both of those are divisible by 5. And that tells us then that 1 centimeter is going to be the same as 20 meters. So there is our drawing scale. Then for part B, what is the actual width of the soccer field? Well, the width has to be the shortest side since we've already worked with the length here. So we don't know the actual width of the soccer field, so we're going to call that x. We can set up with the 1 centimeter to 20 meters. We will also have another ratio. Again, because this was drawing compared to the actual, we should also have drawing to actual. Now we can set up a proportion, so 1 over 20 is equal to 3.5 over x. We will cross multiply. X equals 20 times 3.5. And that tells us then that x is going to be 70 meters. All right, this time now we're talking about the distance between two cities in Europe, between Paris and Milan. We're told that that is 640 kilometers. And then the distance between them on a map is 16 centimeters. So we are being asked first to find the drawing scale. So as usual, let's start by just setting up a ratio. We're going to have 16 centimeters to 640 kilometers. And now let's start simplifying this as much as we can. I'm not sure if that is divisible by 16, so let's try. Yeah, it is actually. So it is going to be by 40. So if we divide both of these by 16, we're going to get 1 centimeter, and that is going to be 40 kilometers. I'm going to check my work just to be safe. And yes, that is correct. And again, the way that I figured that out was I did 640, I cut it in half to get 320, I cut it in half again. So I knew then that I had to divide by 2, and then to get to 16, divide by 10. And that's how I figured out that it was going to be 40. Okay. Now that we have our drawing scale for part A, we are told then that in part B, the distance between Paris and Frankfurt, Germany is going to be 11.2 centimeters on the map, and we're supposed to find the actual distance. So now this time, here is the map distance. That's going to go first. And then we need to put in the amount that we're trying to find, and that is going to be x kilometers. We can go ahead and set up our fraction. It's going to be 1 centimeter over 40 kilometers equals 11.2 centimeters over x. We will cross multiply. We get x equals, and then we have to do 40 times 11.2. Okay, so we got zeros for the first one. This would be 8, 4, 4. Oh, I could have done that in my head. Oh well. 448 kilometers. So I did tell you a little bit about earlier, we often use scales with blueprints. And so while it's kind of a primitive kind of blueprint, I suppose, showing then the layout for a 1-bedroom apartment. So it says Kevin lives in this apartment. He uses the floor plan to calculate the actual dimensions of the living room and the bedroom. He is told that the actual bedroom has a length of 5 meters and its width is 4 meters. So it's a little tough to see, but it appears as though this is going to be the long side. So I'm going to call that 5. And then we are told that its width was going to be 4. And the question, part A, what is the scale? Well, we see that the 5 meters and the 2 centimeters there are lining up. So let's go ahead, write 2 centimeters to 5 meters. Once again, we need to put this in simplest form. So let's divide the left side by 2. And we're going to get 1 centimeter is equal to 2.5 meters. Okay. Then for part B, we need to find the width of the bedroom. So this time, what we're going to do is, we don't know the drawing, how long that is. So our ratio is going to be a little bit different. This time we're actually going to have x centimeters compared to 4 meters. And that's going to be paired then with the ratio that we found in part A. We're going to get 1 centimeter over 2.5 meters equals, and then it's going to be x centimeters over 4. We're going to need to cross multiply. Over on the left side, 4 times 1 is going to get us 4. On the right side, 2.5 times x is going to be 2.5. And I'm thinking I might want to take that 2.5 and turn it back into 5 over 2. So that's what I'm going to do. That's going to help us solve this, because then I can multiply both sides by 2/5. Or some of you would have said divide by 5/2. That also would be the same thing. Then simplifying over on that left side, that is going to get us 4 times 2 is 8. We're going to divide it by 5. And that is going to be equal to x. And so our units, if we include that, would be 8 over 5 centimeters. If you want, you can also figure that out as a decimal and that is going to be 1.6 centimeters. Then for part C, we are being asked what is the actual length of the living room? So we are given the 2.4 centimeters up here, and back from earlier, we found that we had 1 centimeter is going to correspond to 2.5 meters. So now that we have that, we can go ahead and write in, we've got x meters. Our scale is right here, and then the ratio, the second ratio that we're going to use is the 2.4 centimeters to x meters. We'll set this up then as 1 over 2.5 equals 2.4 over x, and we will cross multiply. So x times 1 is x, and 2.4 times 2.5, trying to do this one in my head to make up for the one before. Let's see, we're going to get 4.8 and then half of 2.4. This should be 6. We should get 6 meters. I will double check this one. And yeah, it does end up being 6. Okay, so I want you to try this one then. You are given a scale in this picture, and you are asked to find the actual distance that this man walks from the train station to his house. So pause the video, and then when you are done, start it up again, and I will tell you what the answer is. Okay, so our scale that we were given was up here. It says 1 centimeter corresponds to 100 meters. So every number in this picture had to be multiplied by 100. And therefore, instead of 3 centimeters, we were going to get 300. Instead of 2.6, it was 260. We get 280. We get 180. And we get 260. And then we just need to add all of those numbers together. We're going to do a lot of addition here. We know we're going to end with a 0. Then let's see, we got 8, 16, 22, 28. And then 2, 5, 6, 7, 8, 9, 10, 12. So we find that the man walks 1,280 meters. And that's everything. So make sure to check Sabas digital platform to see which questions are required and which ones are optional. Thank you for listening, everybody. Have a good day.